Hello everybody and welcome back. In this video we'll be learning about queue data structure. So what is a queue data structure? In Java, a queue is a part of java.util package. The queue data structure follows first in first out principle. Unlike stack data structure, queue follows first in first out principle, meaning that the elements are inserted in the queue at the end and removed from the front of the queue. And it is commonly used for tasks like print queues, breadth first search in graphs, and messaging systems. Here's a pictorial depiction of queue data structure. Here you can see box number 3, 4, 5, 6, 7, 8, which is a representation of node in Java, is lined up as an array list, and the node 3 is marked as a head or the front of the queue. Then box number 8 or the node number 8 is marked as the tail of the queue. Because it follows first in first out principle, the first one to the queue is 2 or 3. So whenever a dequeue command is given, the element at the first or the front of the queue is removed, similar to a normal queue that we must have encountered in our real life also, right? So it's similar to that only. Now let's go ahead and talk about the characteristics of a queue. Here are some of the methods. Add or enqueue is used to insert an element into the queue, and it throws an exception if it fails. Dequeue/remove method retrieves and removes the head of the queue and throws an exception if the queue is empty. Peek method is used to retrieve but does not remove the head of the queue and returns null if the queue is empty. So remember, peek method is used to get the head of the queue, but it does not remove that element from the queue. And is empty method is a simple method which checks if the queue is empty or not. Use cases. We'll talk about real world use cases. So some of the real world use cases is call center or customer supporting queue. You must have encountered, right, in a call center, whenever you call for any service, like when you call for Amazon shopping, right, there you must have faced that the IVR or the automatic voice system would suggest you that you are in queue and you're waiting for the person ahead of you to get it done, then your chance will come, right? So in the same case, this customer support system requests from the customers are queued and processed one at a time. The first request that comes in is handled first, thus it is called first in first out principle. Then it is used in printing or print queue methods. In printing system like normal printers or enterprise level printers, multiple print jobs sends to the printer which are queued, and in the queue order they are received. The first job in the queue will be printed first, right? Another example, in the real world example, can be internally under CPU task scheduling. In a computer operating system like a Mac OS or Windows OS, the tasks are scheduled in the queue, right? And the CPU processes the task in the order they are placed in the queue. Another example can be used in algorithms and data structures like graph. So for doing breadth first search in graphs, BFS uses a queue to explore all the node levels by level. These nodes are dequeued for exploration and their neighbors are enqueued for further exploration. Another use case heavily used in many of the enterprise level application is it is used in systems like Kafka or RabbitMQ, where Kafka and Java applications are integrated. They are used heavily where messages are queued up and processed in order they were sent. So here are some of the examples for use cases relating to the real world in terms of queue data structure. Now let's code this. Here we will code a simple queue example by utilizing the existing queue data structure provided by java.util package, and we'll move to the IntelliJ. And if you are new to IntelliJ, I would suggest you to go through the given below URL. Here it describes getting started with the IntelliJ IDEA development environment. So let me exit from this and we'll move to the IntelliJ screen. Here I have a project, simple project, and under the YouTube directory there is a DSA directory. I will create a new Java class called QExample. Let's create a class called QExample. Give it a main method that would be a main thread, and it would be the main entry point of our application. So let's utilize the queue data structure provided by java.util package. So let's first import java.util.queue, right? Because it is a queue, we will mention queue of strings. In this example, I'll try to demonstrate an example of a certain bank queue, let's say. So let me give a bank queue. The name will be bank queue, and it will be a new linked list. So internally it uses a linked list, thus we have to define it as a new linked list. So this queue data structure, if you look at, you can see it is an interface which extends collection, and this interface is internally used for doing many processing, like given an add or remove, or add is equals to enqueue method and remove is equals to dequeue method. And there is an offer method, there's a poll. There are multiple methods available in this interface. So let me give it a queue string, but it is given implementation, so better we mark it as a linked list, right? Sorry, right. Now what are we going to do is, let's say our bank opens at 9 or 10 a.m. in the morning, and then people are starting to come up, going to the customer desk, and everybody is asking for their services to be done. So at one point of the time, the number of peoples are increasing, and not much efficiently those are processed. So what happens is, there is a need for people to be aligned in a queue. So for that purpose, let's say what are we going to do is, we create a bank queue. Then in the bank queue we add, let's say person named Raj is waiting, so he will be added first in the queue. Then there will be a person called Sam, then there will be a person called Ram, right? So basically Sam will be waiting, then there will be, sorry, the first person will be the Raj, and there will be Sam, and then there will be Ram will be waiting, right? So this is how the queue data structure is created. Now let's say a person issues, say I want to know who is the first in this queue. So what I will do is, basically I will say, first of all, let me print out the whole queue. So queue will be bank queue, sys print. Then let's say I want to know which is the person at that first first person. So let's say first person, and then I will say bank queue dot peak method is used to, if you look at this definition, see it says peak method, right? So peak method is, it retrieves but does not remove the head of this queue, and returns null if the queue is empty. And let's print out first person in the queue is first person. Then let's run this to test if this is working fine. So the step one is, basically we'll, in the development now, we'll keep step by step development process. So the step one will be creating a queue. So first step will be, we'll create a queue. Then in the second step we will is add the element to the queue, add element to the queue, right? And then in the third step, based on the requirement, we will add or remove the element from the queue. So here firstly, when we run this program, we can see that there is the queue list where all the users are available, and the first person in the queue is Raj, because he's the one who was firstly added to the queue. Let's say if I add bank.queue dot add, it's a my name to the queue, and when I run this, see the queue is Sandeep, then Raj, then followed by Ram, then followed by Ram, or Sam, then followed by Ram. So the first person in the queue will be Sandeep. So he will be the first one who will be served, and then the next one numbers will be Raj, and the third number will be Sam, and the fourth number will be Ram. Right? That's simple. Then let's explore another method. Let's say we wanna remove. So now the person named Sandeep, who is first in the queue, is been served. Now we'll have to first remove that person, right? So that the next person's number comes. So what we can do for in that purpose is, we will say uh, bank.queue.remove. Now with this remove command, if you look at the description of this method, it says it retrieves and removes the head of the queue. So head of the queue right now is Sandeep, so he will be removed from this queue because his task is done. So what we're gonna do is we will save this and we'll say person served sprint person removed, right? And after that we'll again print who is the next person in the queue. So we'll name it as, we'll not define it because already defined. Now let's rerun this. So firstly the queue was built, then when it was initially running, the person who was on the first of the queue was Sandeep, he got processed and removed. So now he's removed, so the next person is Raj. Now the first person is Raj. Let's rerun this. So this is, I think that's it. This is the simple queue example. Internally it uses interface and it has different methods and different methods such as add, peek, remove, right? So in the following video what we'll do is we will build our own queue and implement this add and remove methods, right? So before we end this video, I like to demonstrate a small graphical video explaining how the elements are added to the queue and removed from the queue. So moving back to this, let's play this, right? So when a new queue is added, a new element added to it, suppose one, in this case, one is added, then a new person number two is added. So you can imagine like person one is Sandeep, then the person number two is what was the person of Raj, then the person number three is Sam, and the person number four is Ram. So these are basically connected nodes, right? And then the last person will be pointing to nothing, it would be empty, right? And the first person, which was Sandeep, will be marked as the head of this queue, and the last person, node number 4, Ram, will be marked as the tail of this node. So whenever the enqueue operation will be done, let's say after Ram there is a person called Sham is going to add. He's also wanting to go for bank service, so he'll come and wait in the queue. So he'll be enqueued in this queue. So when the person name value node number 5 named Sham is added to this queue, what will happen is it will be added to 4 after 4, and then the Sham node will be pointing to null, and then the tail will be moved to the newly added node of the queue. This is how the enqueue will work. And let's say we have 1 2 3 4 and null, and then this is the head and that is the tail. When a dequeue is done, the person number 1 will be removed from the queue and the head will be moved to the next element or the next person in the queue, right? Simple, right? Up till now I hope you are clear. We'll get more clarity in the next video where we'll be code our own dequeue and enqueue method. For now, thanks for watching. In the next video we will code our own dequeue and enqueue method and peek methods. Thanks, have a nice day.